did you learn in elementary school? How to change a mixed number into an improper fraction?
Yeah.
Nick Mathis, talk us through the process. Yeah, I want everybody to do this just as a reminder. The whole number times, like Nick said, in this case, the denominator, which is 3. Then what? And then add the numerator. What's the denominator? Right, if it helps you, make the denominator first, because whatever the denominator is in a mixed number, whatever the denominator is in the mixed number, that's going to be the same denominator in the improper fraction. So you take the whole number times 3, which is 3, and you add the numerator, which is 2, and you get 5/3 is the equivalent. What about this one? What do you get? We know it's something 12ths. Jake. Correct. This has to come pretty readily to you, or you'll struggle in lesson 2. Because really, lesson 2 is just an extension of lesson 1 from last week. The only difference now being is that you'll be dealing with improper fractions and mixed numbers. All right, read example 1 quietly to yourself. All right, first the think statement. How many what are in what? Good, Val. Correct. Kind of like what we've been doing last week. The difference now being is we're dealing with mixed numbers, which is the same as dividing 1 3/8 by 2/8. Now, in order to model it, what we want to do first is take our mixed number 1 3/8 and change it into an improper fraction. So what's 1 3/8 as an improper fraction? Kaylin Mallory. 11/8 is correct. And then when we rewrite the think statement, it's how many 2/8 are in 11/8. We're going to model it 2 ways. First, I'll show you the fraction bar. So right now, count up the boxes and tell me how many you got. Control it. Each one is worth what, Tim? What's the value of each box? Correct, 1/8. Do we have enough? Is there enough boxes? Yes or no? There is not enough boxes because, remember, we have to shade 11/8. So we're going to need to extend this even more. As you'll see, how many boxes will you need? At least 11, as you'll see, you're going to need one more, but you'll need 12. So this just summarizes what we talked about. Each piece is 1/8. The entire fraction bar is 8/8 or 1 whole, and it's not enough. We need 11/8 or 1 3/8. This now becomes the new fraction bar. Count them up, make sure it's 11. Right? Okay, don't go ahead. Where are you good. How many are you going to shade? Inch. How many? How many can you shade? Shade. Yeah, shade 11. Just to recall from last week, because it's been 4 days, this is your shade, this is your group by. All right, let's group them. Count them with me.
1,
Thank you.
2,
Not there yet.
3, 4, 5.
Now what? Partial group, right? Even though there's not a box here, we're going to make. Everybody see 5 1/2? Once I've changed them into improper fractions and the denominators are the same, you're right back to what we did in lesson 1. No difference. But like I said, it's been 4 days since you've done it, so it's kind of a little bit of a refresher anyway. So there's 5 servings, with each serving being 1 3/8 in size of strawberries. In essence, that's kind of what we did. I'm going to show it to you using a number line, and once we see the number line, it is actually a lot quicker. Same idea, they almost look like boxes. I'm going to rewrite the problem here, and I'm going to introduce 2 new words to you that become critical from here on out. That's going to be called our go-to fraction. This is going to be our leap by. Now, when you change it to the think statement of how many, everybody see this? How many, what, and what? Say it.
How many tickets are in 11 or 1?
Okay? Once you flip it, this is now our go-to, because we flipped it. It was when you have it as a division expression, 11/8 or 1 3/8. That's still our go-to, and this is still our leap by. So once you get your go-to, remember that each one of these lines is an 8. So there's 1/8, and 2/8, 3/8. Let's label it.
4, 5, 6, 7, 8,
Or 1 whole,
1 and 1.
or 9/8. Let's keep it improper.
11/8, 12/8. That's a little bit.
Okay, my go-to is 11/8. Make it like a dotted line here, so we know where we're going to on the number line. And leaping in groups of 2/8.
3, 4,
5 1/2. Everybody see why it's 5 1/2? Some kids want to put 5 1/8. All right, be careful with that because it's 1 or halfway between 5 and 6. let's do this one together. Read it quietly to yourself. All right, first the think statement. Eth, how many what and what? Here you go. How many what and what? Don't attempt to change anything yet. As is. We have two fractions, right? How many what and what? Chuck. Correct. Or we're dividing 1 3/8 by 3/4. Your first goal is to take your mixed number and change it to an improper fraction. That's a state. We'll have one more other step before we can go to the number line. So this we've already done. 1 3/8 becomes what? As an improper fraction. 11/8. We already did that. And now we have one more other layer to do. 3/4. How to make 3/4 and 11/8 still requires one more other step. How is it different from the first example? So, correct. You have to have, at some point, in order to use the number line or model it, you've got to have the same denominators. So it's different because the denominators are different. You remember back when we did ratios, right? We did equivalent ratios, right? You want to take your 3/4 and change it to an equivalent fraction that has a denominator of 8. This stays 11/8. What does 3/4 become? Matthew. Right. If you times both the top and the bottom by 2, you now have 6/8. It's an equivalent fraction, much in the same way as we made equivalent ratios. All right, now we can rewrite the think statement in the form of 8s. How many what and what? Michael.
How many 6/8 or an 11/8?
Sounds good. Or are we good so far with understanding this? Because I want to try something else with you coming up.
Yeah.
Are you good with understanding how we got to how many 6/8 and 11/8? Tim Gann, you good with this? Since we know, Jordan, since we know that the denominators are the same, are you okay with trying to figure out how many 6 is an 8? Stop me if you don't understand that leap. Oh, how many 6 and 11, sorry. Is that what you're going to say? Are you okay with how many 6s are an 11? Yes. And then when we make our number lines, since we know that everything is in 8s, are you okay with counting by just the numerators? Because this is really 1/8, this is 2/8, 3/8, but since our denominators are the same, all we really care about is how many times the numerator goes into the numerator. So all I'm doing is just giving me less to write. But if that's confusing to you, then put everything over 8. What's our go-to? where do we have to go to on the number line? Sam. This is my go-to. Make a dotted line. By how many? You've already started to do it. Not by 2. Lead by 6. Get that terminology into your head. Go to lead by, because it will work for everything as long as the denominator is the same. Do I have one full leap? I do. I'm good. There's one. Do I have 2 full leaps? It's partially. Because to get from 6 to 12, I actually go past my go-to. So we have one full leap. And here comes the tricky part. How much of a partial leap is this? This is always the hardest part for students. Geo. Kind of on the right track, but not 1/8. Tell it. Let me say 5/6. How'd you do it? He's right. It's 1 and 5/6. I want to know how you did it. How you figured it out. Okay. How many blocks are there altogether? How many lines are there from this leap to the next leap? How many leaps is that? How many pieces is that? And we have technically, our go-to is 1, 2, 3, 4, 5 out of 6 parts of the way. So the answer becomes 1 and 5/6. This is always the hardest part for students because they want to say, I've seen 1 and 5/8. I heard that because our denominator is an 8. Our denominator of our answer is not necessarily going to be an 8. So this is the part that can get confusing, is how to determine how much of that partial leap is in the full. The easiest way to remember it, once you have a partial leap, here's what you can do and say, okay, to get from here to my go-to, 1, 2, 3, 4, 5, numerator. The full leap is 1, 2, 3, 4, 5, 6, denominator. If that helps you. And honestly, the best way to learn it is just keep practicing and practicing and practicing. It's like learning a new thing. So the answer becomes 1 and 5/6. Now what? Well, let's first do the think statement and then realize we have to do 2 things here before we can begin to model it. First of all, what and what? How many what and what? Always do that first. Yeah. How many what and what? NOS. Think statement. Give me what and what? Are you sure? I want you to be sure. You sure? How many 2/3 and 3/4? What do we have to do though? Can't even attempt to put it on a number line yet. Jordan.
You have to find the fractions.
Or you have to get a common common denominator. Okay? And he's already suggested that our common denominator should be 12. I agree. Well, look, you're right back to what you did in the ratios unit. Times what? Times what?
4.
So what you've done is you've made equivalent fractions for each fraction that has a common denominator of 12. Rewrite the think statement now. How many what and what? Go about. Good. Denominators are the same. That's our goal. What's our go-to? What's our elite by? Aldi. What's our go-to? What's our elite by? Okay. First, let's label this. Again, are you okay with leaving these as whole numbers? Even though they're not whole numbers, they're just numerators. I wouldn't even call them whole numbers. They're numerators out of 12. Okay, Tim is right. That's our go-to. Tim Gann, what's our leap by? Okay, bud, do I have one full leap? I'm good. Next leap, partial or full?
Partial.
To where? Where's the partial leap got to land? No matter what. No, where? No. Leaping by 8. Where's that second partial leap landing? Lands me at 16. So we now know it's going to be 1 full leap. Here comes that tricky part. What's my fractional value? Tell you what, write it down on your sheet. I'm going to come down and I'm going to take a look. I'm going to do a walkthrough. This is still my go-to, right? Still my go-to, right? 1 and 1 out of 1, 2, 3, 4, 5, 6, 7, 8. 1 and 1/8. It's the partial leaps that's going to take the most practice for you guys because it's tough to say. The shortcut, if you want to use it, as long as your denominator is the same, is dividing the numerators when the denominators are the same. So if we rewrite this, again, how many? Is there room at the bottom of page 7? Going back to what we were doing, it's how many 8/12ths and 9/12ths. The denominators are the same. Yes or no? I feel like I'm talking to nobody today. Too much turkey?
Yeah.
Too much tryptophan. You know what tryptophan is? It's in turkey, it makes you sleepy. You guys have turkey coma. Are we okay with saying that the same as how many 8/12ths and 9/12ths is really how many 8 and 9? Or does that throw you for a loop? Who's in the house? Who's outside the house? Joe. Who's out? Ready? 8 goes into 9 how many times? Wake up. Thank you. Who's how many left over? Ready? Remainder over divisor. 1 and 1/8. But remember, if you're going to do the shortcut, you have to get to the common denominators first, whether that's changing mixed numbers, doing proper fractions, or changing unlike denominators like we had to do. You have to scale up or scale one down, otherwise it will not work. Alright, so here's your task. And I might as well give you your assignment also. How much time we have left?
5 minutes.
Okay.
Like,
Go back to your, open up your agendas, which I'm going to give you the homework now, but you have 5 minutes to start this in class. For section 1-3, I want you to finish through page 10. Okay? That's your assignment. So, our last example that we just did was what page, guys? 7, right? So you've got to do pages 8 through 10 starting now. Whatever doesn't get done in class has to be done for homework, and I'm going to check tomorrow. We can't move on to the next level until we can master 8 through 10.